These are the lesson 10.3 notes on the quotient of powers property. In 10.2, we looked at the product of powers property. So the quotient is just the inverse of the product, right? So those two properties are very closely related. The key idea in the quotient of powers property is that to divide powers that have the same base, that's important, you can subtract their exponents. So when I look at numbers, 4 to the fifth power divided by 4 to the second power is 4 to the 5 minus 2, which is 4 to the third. And if we write that out, you can see 4 times 4 times 4 times 4 times 4 divided by 4 times 4, and you can see that they cancel out, leaving you with 4 to the third. The nice thing about working with exponents is that if you forget what the rule is, which you probably will because the rules sound quotient of powers property, the rules are very sound confusing, but you can always expand it out and cancel and get the right answer. So even if you can't remember what the exact rule is, you can always figure it out. When we look at that algebraically, if I've got a to the m power divided by a to the n power, that is a to the m minus n. And remember that a cannot be 0 because you can't ever divide by 0. That's undefined. Okay. So in this first example, I've got 2 to the 6th divided by 2 to the 4th. Using my quotient of powers property, I can rewrite that as 2 to the 6 minus 4 power. That is 2 to the second power, which is equal to 4. Actually, I think for the purposes of this set of notes, we should leave it like this. We're going to leave it as a power rather than evaluating it, at least in this section. All right, so for B, you can rewrite that as negative 7 to the 9 minus 3 power. That's the same as negative 7 to the 6th power. And notice that you have to keep the parentheses because we want negative 7 raised to the 6th power, not the opposite of 7 raised to the 6th power. And for C, so using our quotient of powers property, I've got h to the 7 minus 6th power, which is h to the first power, which is just h. So let's see if there's anything weird here. No. Notice that everything has the same base. And then we have two different examples where we are simplifying, I should say, an expression. We're going to look at this, maybe this one, two different ways. So in example 2, we're first going to, I'm going to rewrite this, 3 to the 4th power times 3 to the 2nd power divided by 3 to the 3rd power. So when we have this fraction bar, that's the same as a grouping symbol. That's why we say GEMDAS instead of PEMDAS, because there are different kinds of grouping symbols. It's not always parentheses. So we need to do the whole top here first. And what I see in the top is that I have the product of powers. I have the same base, 3, raised to a power. So using my product of powers, I can do 3 to the 4 plus 2 power. I'm going to write that down. over 3 to the third. And then I can simplify, so 3 to the 4 plus 2 is 3 to the sixth over 3 to the third. And then using my quotient of powers property, looks like I need a little bit more room, I'm going to have 3 to the 6 minus 3, which is 3 to the third. And then when we get into example 3, we're actually going to do this one 2 different ways. You've got 2 different options. Let's start with using the quotient of powers first. So I've got, let me just rewrite the problem, a to the 10th over a to the 6th times a to the 7th over a to the 4th. And so using that quotient of powers first, I can do a to the 10 minus 6th power times a to the 7 minus 4th. So that's using quotient of powers. And then a to the 10 minus 6 is a to the 4th times a to the 3rd. And then I can simplify that using the product of powers, because now I've got a to the 4 plus 3 power, which is a to the 7th. So then I used product of powers here. However, you could do it in the opposite direction. So you could do it like that, or a to the 10 over a to the 6th, a7, a to the 4th. Or you could use your product of powers first, right? Because you can just multiply numerators and multiply denominators. So if I do multiplying the numerators, that is a to the 10 plus 7 over a to the 6 plus 4. So now we've used the product rule first. And so I have a to the 17th over a to the 10th. And then I can use the quotient of powers, and I've got a to the 17 minus 10 is equal to a to the 7th. So then we used quotient here. Whew, thank goodness they came out the same. That would have been awkward. All right, so when you're looking at your problem, lots of times you have more than one way to do it, and it doesn't matter which way you choose, they should give you the same answer. Yeah, I'm looking here, and those are just the same, so that shouldn't be too tricky. Okay, and then we have this real-life problem. So we have the projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th power. We want to predict the average number of people per square mile in 2030. And we're going to use this model to solve the problem. So the people per square mile, which is what I'm trying to find out, is the population in 2030 divided by this land area. So the projected population is 5 times 5.9 to the 8th power. This, we'll call them people. And I divide that by this land area of Tennessee, which is 5.9 to the 6th power. That seems a little convenient, don't you think? I wonder if they made up these numbers. Okay, but anyway, you can't combine these two things together. Remember that you have to have the same base. So the base here is 5.9, so you can't add this 5 over here, even though they're both 5s. You have to go ahead and do this first. So let's rewrite this as 5 times 5.9 to the 8th over 5.9 to the 6th. And then using my quotient of powers, that is 5 times 5.9 to the 8 minus 6, which is 5 times 5.9 squared. I really feel like I need some parentheses there. Okay, and then I'm just going to use my calculator to find a good answer. So we've got let's do the exponent first, right? So 5.9 to the second power equals, you don't have to push the equals, times 5 equals, and I've got 174.05, which is going to round to about 174 people per square mile. And then you have an almost identical problem, except that we're looking at Alabama, and their projected population is 2.25 times 2 to the 21st power, and here is their area, their land area, 2 to the 17th, and you're working in kilometers, but it makes no difference. You do the problem exactly the same way.